Hey guys, third time's the charm here. It seems that we're having some technical difficulties, and I got Jossi right back in here. Welcome back,
Hey.
Jeff. We're live now,
Thanks.
actually.
Nice. All right, let me look at my audio settings just to make sure. Yep. All right. I'm so sorry. It sounds like my computer is running a Gradle build. I don't know what's going on, but it is what it is. Let me go ahead and share my screen. All right. How are we doing in terms of people? Do we want to wait a couple more minutes, or do we have folks here already?
So what I'm going to do is I am going to share this YouTube channel, and then I have to get this into the meetup again. I apologize to them for changing it like 3 times.
Fine. Hey, nice to see you. Are you, wait, what is that icon? Does that mean you're joining through Periscope, Manish? Is that, or are you viewing this stream on YouTube?
Yeah, I think they can actually stream through Periscope.
Wow.
So yeah, we have Periscope, we got YouTube, and we got Facebook right now, I think, at the moment.
I didn't know Periscope was still a thing. I've never been live on Periscope, I think.
Isn't that crazy?
Yeah.
You should actually share. Feel free to share the link. Yeah, absolutely. Yeah. I'm going to do that. And the link is today's event. The link is this. We had technical issues the first time trying this tool. Cool. Yeah. Shoot. I don't know if that's actually the link. God damn it.
It's a link to the YouTube channel. That works.
It does. I think it'll work.
You know,
takes you to the channel.
Our audience is kind of tech savvy, I hope.
They'll figure it out.
I mean, yeah. I hope that not everybody's as lost as me with tech. So.
Yeah. I can give you screen sharing permission here. There we go.
Yeah, I think I might already be sharing, right?
I think so, but I have you maximized, so I'll undo that. There you go. This is very, very new. I have no way of telling how people are on the stream right now. Oh, there we go.
Oh, I do. Yeah. All right. Let me wait like 2 more minutes to see if more people come on. In the meantime, I'm going to tell you a life lesson, which is there might be technical problems ahead of the stream, and don't try to, don't plan to shave in like the 5 minutes before the actual meetup starts because you were kind of finishing slides before. Don't do that. Always shave before. Now I know, but it's a public holiday here in Germany, so I forgot. And it's left long. Yeah.
Cool. Very cool.
All right. Other than that, let me pull you onto my other screen. And then let's get started. Do we know if people are, I'm kind of concerned that people haven't figured out that this is the link. But we'll just get started.
Yeah.
If you're good with that.
That's good. I think we're great with that. I'm going to just actually send another comment with the,
yeah.
Let's see. Okay, 1 sec. I'll send it out. You can get started, but I will share this out.
Cool. Sounds good. All right. Well then, hey everybody, thanks for coming here, for attending, for joining over maybe lunch, or it might be in the morning for you, or it might be in the evening on a public holiday if you're in Germany. I really appreciate everybody coming here and listening. Today I'll be talking about some StateFlow shenanigans and SharedFlow, kind of lessons that we learned while using it, that we learned the hard way, and kind of like things that I totally wished somebody would have told me before. Maybe I should have read the docs more closely, but you know how it is, right? I'm Jossi Wolf. I'm a Google developer expert for Android, and I work at Snap Mobile, which is this kind of like agency / consultancy thing. And as such, that means we kind of get to see a lot of different and cool projects. And recently we've been working on a greenfield project actually, and we decided on Android to go for Jetpack Compose, which is super, super cool and exciting. And with that, we also were like, do we really want to continue using live data? In our old code base, we were using live data and things were working fine, but we thought maybe it would be good to just go with the flow, just go use StateFlow and see what happens, because who knows? And yeah, these are the lessons learned. Lesson number 1, just use Rx. I was seriously tempted to go and have this be the whole talk. During all of the kind of StateFlow time that we use StateFlow, or when we started using StateFlow, I was seriously frustrated because things weren't really working as I expected them to, rightfully so. They shouldn't have been working how I expected them to, but things could be a little counterintuitive for me at times. And I really held this sentiment for a bit, where I just went, ugh, I don't want to use all this new stuff. I just want to go back to the good old days and use live data or Rx or async tasks, I guess. So what the hell is StateFlow actually? So we're at a Kotlin meetup, so I guess everybody at least has heard of Kotlin flows, which are a essentially sequence version that support coroutines. A StateFlow is a Kotlin flow that is hot, and we will look at what that means in a second. I mentioned live data before, and I just want to kind of go back to what we were using that for. So when you're building mobile apps, when you're building something that has a UI, you have to necessarily think about the case of your UI component, be that a fragment, activity, a composable, a Swift UI view, or really whatever, going into the background, or going into a paused or a stopped state and then getting resumed and restarted afterwards. And with that, you always can have the issue of trying to figure out from your presenter, wait, is the UI component actually in a valid state to render UI right now? Should it even render UI right now? Because if you are in a stopped state and you try to set a button's text, well, obviously that's bad because you're not on screen. And that's kind of a long-running issue, long-standing issue, especially on Android, where life cycles aren't necessarily the easiest thing to understand ever. And in 2017, I looked this up. I totally thought it was 2016. In 2017, Google made this push for architecture components and announced and introduced live data, which was an observable holder pattern implementation that was lifecycle aware. So you could go and take that live data. You could observe it from your UI components, and you could be sure that the observer wouldn't be called when the UI lifecycle, when that component's lifecycle might be stopped, paused, or whatever. Anything where you shouldn't really be listening to these kinds of changes. And essentially, all of this is for the tiny niche issue that we think about a lot of getting state from the presentation layer to the UI. And yeah, so live data became really popular, and then at the same time, kind of Kotlin became really popular in the Android community, and then coroutines became more popular, and then Flow became more popular, and people were kind of like thinking about, hey, live data does have its issues. What if we actually had a flow that could essentially do the same thing, right? That would be super nice. Not only wouldn't we be bound to all the Android component stuff, right? We could go multi-platform, but also it would be a lot more uniform, right? Because we would only be using flows, probably flows and coroutines instead of flows, coroutines, and live data and whatever. So at some point in actually 2020, last year, I think the first discussion started around 2019. I'm sorry, all of last year is a total haze for me, so I couldn't tell you if it's 2019 or 2020. This issue was opened in end of April 2020, so roughly a year ago, about introducing StateFlow. So this was kind of the first proposal for, hey, we wanna have something like that in our coroutines library. How should we design it? What should it look like? Got the community involved. So in the end, I mentioned earlier, a StateFlow is a flow that is hot. I briefly want to look at, before we look at more StateFlow stuff, I briefly want to look at hot and cold flows. Yes, hot and cold flows. So what even is a cold flow? Kotlin flows by default are cold. That means that they will be restarted every time, that they will be started only when you collect them. And when there is no active subscribers, they will end. So if we were to take this code with the flow builder and we generated a random number, then we emitted some string with that random number, and then 500 milliseconds later, we emitted another string with that number. And then we collected that. We get hello with that random number, and then guten Tag, which is German, good day, with that same random number that we had before. If we were to run the collect again, we would see that we would get a different random value to before, because that flow builder would be, that upstream would be invoked again and would be rerun. Now, a hot flow is we're going to take that same flow builder that we just had, generates a random number, and then emits something with that random number. And we're going to take this cold flow and we are going to convert it into a state flow using the state in function. Now we'll look at that more closely in a second. And we're going to do the same thing that we did as we did with the cold flow. So we are calling greetings data collect, and then we are printing with a 1 prefixed that emission, and then with the then we're doing the same for another collector. And you'll see that we are. I totally forgot to add the guten Tag emissions, but let's ignore that for a second. You'll see that we are printing the same random number in both collectors, which is obviously a different behavior to cold flows. This is super helpful and nice, because if you think about state in your app, or whatever, really, if you think about state, if you think about some UI component that connects to maybe a presentation layer, a view model maybe, and then tries to read that state, you don't want to re-trigger everything every time you want to read that state. So these are, this is kind of the use case for hot flow over a cold flow, and that's why you need a state flow to be hot. The same thing, this also means in a cold flow, you really do not have the concept of the last value of the latest value, right? It emits that value, and then the collector receives it, and then it's gone. And it's not kept. In a hot flow, the value can be kept. Doesn't have to be kept, but it can be kept, which is something that you definitely want to have for state, because you might have a UI component that that looks at the state, grabs it, and then does something, and then the UI component disappears, and then it reappears for some reason, and it reconnects and wants to get that same latest value again without retriggering all loading of data, which could be slow. All of this is to say StateFlow is essentially similar to live data, if you know that, or similar to a conflated broadcast channel, which we'll look at in a bit too. Now, we're already getting into some important gotchas. Number one, StateFlow never completes. It's fun if you, we kind of skipped over, I kind of skipped over why we were doing the launch before. So let's go back to that. You see that first we are converting our normal cold flow to a StateFlow, and we're passing it the global scope. We'll get to that in a second too. And then to collect it, we are launching a new coroutine on the global scope. Don't use global scope, use something else. This is just for exemplary purposes. Since the StateFlow never ever completes, of course, the collect doesn't ever complete. Collect, if you remember, is a suspend function, and it suspends until that flow has completed. A StateFlow never completes, so if you call collect on a StateFlow, it'll just never complete, and that would mean we couldn't collect twice, because that second statement wouldn't be called if we didn't launch it. If we didn't launch a new coroutine in which we collected this value. This is a very important gotcha, which we'll need to remember later. Let's look a bit at the APIs for converting a normal flow to a StateFlow. So there's this suspend function StateIn, extension function on the flow, and it returns a StateFlow of that type, and it takes the scope. The scope is the scope that the sharing is started in. What that means is so generally when you look at cold flows, they have their subscriber, they have their collector, which receives the values. A StateFlow or a SharedFlow does not need any subscribers to be active because it's a hot flow. But it needs a coroutine scope to launch the sharing, to start/launch that sharing of the values. This suspend function StateIn, you'll see that it only takes a coroutine scope. This is a suspend function because a StateFlow always needs a value. A StateFlow does not have a state where it does not have a value. It always needs an initial value. So what this suspend function does is it waits for the first emission from that upstream flow, right, that we're taking there, and then it produces a StateFlow out of that with this first emission as the initial value, and that's why it is suspending, which in our previous example is totally fine for us since we're in a suspending context anyways. If you are not in a suspending context, if you maybe want to set a StateFlow as a field in your view model or wherever, really, you can use the non-suspending StateIn converter on the flow. It also takes a coroutine scope, same as before. It takes a sharing started strategy, which we'll look at in a bit, and it takes the initial value. So that's why it doesn't need to be suspending, because you supply the initial value yourself, right? That could be just null or something representing that maybe data is loading or something like that. The sharing started strategy specifies how the flow deals with the upstream flow. The upstream flow, when I say upstream flow, I'm talking about the flow that we are running this extension function on. There are 3 sharing started strategies. Number 1 is eagerly. So if we set sharing started to eagerly, that means that the StateFlow will eagerly take that upstream flow and it'll eagerly start collecting it. There's a good example for this. So imagine we have this flow, which is the time flow, and when this builder is invoked, we emit the current time from when we first started the program. And so just think of it as a number in milliseconds. And then if we were to use that, we would take that flow. So we would take that time flow, which I have here called flow, and we call state in. We supply the global scope as scope, and we set the sharing started strategy to eagerly, and we set the initial value to null because we just want to indicate we don't have anything there. And then we delay for 1 second. And after that, we launch the collection and we print whatever we receive. So first we receive the initial value, which we set to null. And after that, we receive 146, which is the amount of milliseconds that has elapsed since that upstream, since the program has started and the upstream was evaluated, so that this get current time function was called. This is interesting because we can see if you kind of did the same thing with a cold flow, you would get 1,146 or something here, because you are only launching the collection after 1 second. There is another sharing started strategy. Words are super hard, which is lazily. So that is essentially the same as if you had a cold flow. If we set the sharing started strategy to lazily, and we have the same code as before, same time flow, we will first receive the value null, the initial value, and then we will receive 1,179, which tells us, it actually waited 1 second before that upstream was evaluated and called. There's also the while subscribed sharing strategy, which might be one of the most relevant, or the most relevant if you are doing UI things. So let's say we change up our example a little bit, and we have this flow, which is a flow that just emits a random number. So then we take that flow, we call state in on it, we supply the global scope again, and we set the sharing started strategy to while subscribed. And really important is we set a replay expiration milliseconds to 0. We'll look at why in a second again. I know, delegating a lot here. And we're setting the initial value to null for simplicity purposes again. Now, if we were to kind of simulate having a UI component that that goes into a stop state, right, where we have to cancel the collection. So first off, we have this job, right, that we get from the launch, in which we collect the value, and then after 2 seconds we cancel that job, and then we say, hey, after 1 second we say the UI reconnects or something. We launch another job that collects that the latest value, and what you see is that we first get a random number, and then we get another random number, which tells us that that upstream was actually invoked twice. Because we set the sharing strategy to while subscribed, that means that the upstream will be restarted whenever the replay expiration millis has passed, and when somebody reconnects. So when there are no active subscribers anymore, this will reset after the replay expiration millis has expired. This is super useful in case you might want to model loading states where you have a flow that first emits a value of loading and then emits your actual value, and you have UI that is there, gets the latest state, and then goes into the background maybe, and after whatever 30 seconds, the user decides to re-return to your app to continue doom scrolling. And then they will still get that latest value. But if they return to the app after 5 minutes and your UI try to get that latest value, the replay expiration millis probably would have expired, and they would get a loading state again, and the data would be loaded again, which is the behavior that you want. These were two extension functions on ConflatedFlows that you can use to produce a hot flow, a state flow. You can also use the mutable StateFlow constructor. So StateFlow itself is an interface which represents an immutable state flow. So you can really just read the latest value from there and you can collect and stuff, but you can't mutate the value. There is an implementation which is mutable StateFlow, and that represents a state flow which value you can mutate. So if you were to create that greeting state through the mutable StateFlow constructor, we're passing it an initial value of hello. And then we're doing something similar to what we did before. We are launching a job that we're launching coroutine that collects the latest value from the greeting state and prints it. And we wait for 500 seconds and we set the value to Guten Tag. And after another second, we access the current value of that state just to make sure, is that all still what we want? Is that how it's supposed to be? And you'll see that we're getting the initial value printed hello, and then we'll get Guten Tag, and then we'll get Guten Tag printed again by the last line, because that is the latest value that StateFlow holds. This can be super useful if you're, if you have view model and you might be doing more complex state combination operations, and you want to have something where you can easily mutate, right? Instead of trying to combine tons and tons and tons of flows, which would be a very kind of reactive and unidirectional way to think about that. Mutable StateFlow is essentially really similar, or just the same interface as live data, same API, really. So you won't notice any difference probably in using that. I put the wrong title here. Converting, so you can create state flows in through 3 ways. The suspend state in function, where you supply a scope, but you suspend until you get the first value from the upstream flow. The state in function, which doesn't suspend, where you pass the scope, the sharing start strategy, and the latest value, the initial value, sorry, and then mutable StateFlow, which is just the mutable implementation of StateFlow. So you can create a mutable StateFlow through the constructor. One other important thing, wait, actually there's lots of important things to note, so maybe I'll say that once or twice more. Another important thing to say about StateFlow is conflated. So conflated is a weird term for me, but essentially it means that you will not you'll not receive a value twice. The conflation of StateFlows is equality based. So if we were to create a new mutable StateFlow with an initial value of hello, then, again, we print that latest value there. Then we set the value to hello again, and then to bonjour, we would only get hello once, because these two values, right, that we set are equal. And if you think about, if you kind of think about state, application state or view state, you don't really want to emit the same state twice, because then it'd be more like an event, really. If you have been using flows and channels for a little longer, you might be like, wait, why wouldn't you use a conflated broadcast channel? There is a whole section in the KDocs about this, and I didn't want to kind of like rip off the whole thing. So here's 3 points I think that are super important, but there is more if you want to look at the KDocs. Number one, StateFlow is breed safe. So it means it always has a value. Conflated broadcast channel doesn't have an initial value. So when you try to access that, it might or might not be there, which really isn't something that you want for a state holder. You really want to always be able to access the latest value, because that is kind of logic that you don't want your probably UI that connects or reads that StateFlow to deal with. StateFlow conflation is equality-based, as we saw before, versus as with conflated broadcast channel, it was reference-based. That is especially helpful, right, if you have an immutable data class that represents your view state, that you then always copy, and you always get a new instance of that. Makes a ton of sense for this to be equality-based. It just uses the standard equals implementation. And StateFlow, as the name says, is flow-based. A lot of the channel APIs are not as lightweight as the flow APIs are underneath. And my Hey Google just went on. A lot of the, now went on again, nice. The channel APIs generally are a little harder to understand and not as lightweight as flow APIs are. Conflated broadcast channel will be deprecated or might already be deprecated, and it's superseded by StateFlow just because it's easier to use and covers the use cases better. So I've already mentioned this for quite a bit. Where do you actually want to use a StateFlow? A StateFlow is really what you want to use for communication between your presentation layer and UI components. I think there might also be a nice kind of use case for server side. If anybody is out there who uses StateFlow for server side applications, something that doesn't have UI, I'd be very interested to hear about that. So on Android, really anywhere you were using live data before, you can safely use StateFlow and just drop that in as a replacement. It's especially great for things like a composable. There is a great integration with Compose and StateFlow, especially where on a StateFlow you can just call collect the state, which converts that StateFlow to a Jetpack Compose state, and then triggers a recomposition. That means that this composable will be called again, essentially, and everything will be reevaluated and checked. Is everything still up to date? Whenever there's a new value emitted by that StateFlow. Especially if you look at things like the while subscribed sharing started strategy, this is helpful, especially with Compose, where composable might recompose, which means that that your subscription would be canceled before you unsubscribe, and then you would subscribe again when you would resubscribe when you're actually recomposing again. For all these things, this is really, really useful and a great replacement for really live data, and a great use case for communicating between view model or presentation layer, and UI. Being able to access the latest value is also really, really helpful. Sometimes within the presentation layer and within the view model, you might just need to read back the latest state value to get something. And for that, it's real nice. I know I've mentioned SharedFlow kind of briefly, but I've ignored it for now so far. So SharedFlow or StateFlow. Number one, StateFlow is actually a shared flow. So a lot of these things that I mentioned about StateFlow are actually shared flow things. Shared flow is the base work for StateFlow, and the StateFlow is essentially a really specialized version of a shared flow. A shared flow can also replay values like StateFlow can, and a shared flow is also a hot flow, but it has a couple of different things. Number one, do you need conflation? A shared flow is not conflated. By default, a StateFlow is conflated, and you can't do anything about that. That's just a property of StateFlow. That's how StateFlow works, and you can change that implementation detail. If you do not want to have conflation, use a shared flow. A great example for that would be something like an event bus, where you would really want to re-emit events, no matter if they're equal or if they're not. Whereas with a state, you wouldn't want to re-emit that every time if it is the same. Number two, does it need to be read safe? StateFlow is read safe. It has the initial value, whereas SharedFlow does not have the concept of an initial value. So if you need to be really, really sure that you always have value, and if you want to read back the latest value, you use a StateFlow instead. A SharedFlow does not have that. And do you need to replay more than one value? A StateFlow is a SharedFlow with a replay set to 1. If you want a replay, if you want to be able to set your replay to 0, that means that when a subscriber, when somebody subscribes to that shared flow newly, you don't get the latest value emitted. Or if you want to have a replay of 2, so that when somebody subscribes to that flow, they get the latest 2 values emitted, you want to be using a shared flow. A StateFlow has a replay of 1. You cannot change that because, again, that is something very specific to how state should be represented in a flow, and makes a lot of sense for that use case. So essentially, I think all of these kind of things come down to, are you building something where you want to represent state in a flow, or do you want to rather represent events? So there are so many things to say about StateFlows and SharedFlows, and I could not ever get to them all in a single talk. But one of the most important things I want to talk about is testing, because I really struggled with that. I had so many issues with testing it, just because there are quite a few gotchas. So number one, let's look at this test. And I know these are a couple of lines of code, but does anybody here know, or can anybody spot what the issue is with that test? Because that test doesn't work. I'm gonna say it took me a couple of days to figure this one out. A couple of days of pulling my hair out. Okay, so yes, you know what's wrong?
I think the while subscribed might be the issue. It looks like you're not subscribed at the beginning of the test, right? And so it's going to initially have a value of null.
I'm going to tell you, it wouldn't work if we set it to lazy or eagerly for the sharing search strategy. I tested it earlier and it wouldn't work.
I got it.
This is
No,
good,
no, no.
this
I
is
know
a good
it. I know what
guess.
it is. I have the real guess.
Yes.
To list. To list assumes it completes, and I've had this problem many times when I've used StateFlows that a StateFlow never completes.
Yes. So this is super important. I will get back to that issue in just a couple of slides, but there is one more fun issue before that. If you look at state in, we set the scope to equal this. The fun issue is in how run blocking works. So if you don't know run blocking takes a lambda, in which we run all our test code, and that lambda has a receiver of a coroutine scope. And we set that scope that we want to share the StateFlow in, that we want to start the sharing in, to that run blocking scope. Run blocking only completes when there are no more active jobs within its coroutine scope. So if you start sharing and a StateFlow never completes, SharedFlow doesn't either, so a StateFlow or a SharedFlow, it never completes, you have this active job running and the test will just run forever. If you don't have any timeout configured for your CI, this might be how you learn that you don't have any timeout configured for your CI, like I did. Things that GitHub Actions are kind of cheap, at least. This is really fun. So what we can do is we can just, this is super simple, kind of fix, but it works. We can just add a job so that, this is actually ignored for the run blocking, because we can safely go, it's fine for this to just be discarded whenever we are done with our test, even though this is not a great practice. But Colin, you already mentioned there is another issue. If you were to, so this test works, this is fine, this is all good. If a coworker came up to me and was like, hey, why aren't you using run blocking tests? And I was like, wait, good question. I don't know. I just went for run blocking. I changed it to run blocking test. Same test thing, and it didn't work. It went, hey, you can't do this. There's still an active job. So that was fun. Wait, did I skip something? Yes, I did skip something. I'm sorry. Yes. So if you look at our assertions down there, I hope you can still see them. First, we assert that the first element in that list that we got from the flow is null, which was our initial value that we set as state in. And then we assert that the second element that we got is the payload that we specified up there initially. And run blocking test is essentially really similar to run blocking, but it runs code using a test coroutine dispatcher. And that test coroutine dispatcher automatically advances time. Now, when I mentioned conflation earlier with StateFlow, I skipped one thing. Conflation also means that that updates will be skipped by slow, that fast updates will be skipped by slow subscribers. So in this case, since we automatically advance the time, this initial value we will just not get it into our list. So we'll actually have the issue of getting the wrong data. So if you need to make sure that you get your initial value, make sure to work around that, maybe by using run blocking. So we'll move on to the next fun kind of thing. So as Colin mentioned, right, run blocking test will still kind of go, hey, you have active jobs. So what we'll have to do is similar to what we did before in all our kind of examples where we launched a new coroutine in which we observed that in which we collected that flow. We're doing the same here. We're taking to, calling to list, And then afterwards, after our assertions, we will actually cancel the job, and that'll that'll make sure that we don't have any active jobs anymore. So yeah, make sure to either manually cancel your your jobs, or use run blocking, which also is kind of like dirty. But yeah, keep that in mind. Right. Then things are all over the place for me today. So after fixing this issue where it would tell us, hey, you still got active jobs running, this is actually where we get to, yep, the first element in there, we expect it to be null, but it's actually 0, because that that subscriber just didn't handle it fast enough because it was conflated. And run blocking test advances the time. So we can fix that by actually using run blocking, and that'll make our test work, which is a fun kind of, we went from run blocking to use run blocking test to back to use run blocking. Yikes. Not exactly fun, and not exactly, giving code that you really want to be sure works. Next thing that I would really recommend you to do is use Turbine. Turbine is a library from the folks at Square, Cash App, where they have this awesome extension method on flows. You can call, it's called test, and then you can call expect item, which suspends until we get the next item. And then, so we do that. We suspend until we get the next item. With expect item, we assert that that's null. And then we expect another item, right? Our actual payload. We assert that that's the actual data that we want to have. And then finally, this is really important, cancel and ignore remaining events, which is essentially the same as calling job.cancel, right? Launching the collection, another coroutine, and then calling job.cancel. You'll also notice we're using run blocking here just because there's really no great reason to use run blocking test given all the issues that it can give you. There are even more issues with run blocking test, and joining different jobs in different coroutine scopes, which I have not been able to wrap my head around. Sean McQuillan will be your person to talk to on that. He said he's sorry for causing that issue. But all of this is to say that, especially with StateFlow, you really have to watch out for how you write your tests. You really have to watch out for where are you launching new coroutines, in which coroutine scope, and are you using run blocking? Are you using run blocking tests? Are you actually canceling your job after you're done? Right, all these things that are not really issues when you're building actual UI, but that come to light when writing tests. And of course, you want to make sure that however you consume that flow also can handle that. So yeah, use things like collect the state if you're on Android, or just really make sure that you don't fuck up this handling. There are a ton of more things to say about StateFlow and SharedFlow. This is only the first iteration of this talk. I'm sure there will be more iterations, and definitely a second and third part, because there is a lot to learn. I feel like I've kind of become this old person that goes, use RX, use live data, don't use all the new stuff. But seriously, this was, personally for me, this was kind of like a great wake-up call that you really have to watch out for all of these kind of gotchas with the new APIs. If you are not using Compose on Android yet and are still using fragments and activities, there are even more issues around flows in general to look out for. So make sure to go and spend that time to investigate and to find these issues, especially in your code base, right? Make sure it works for you. Don't do the same thing that we did, which is just go, yep, let's drop it in, because you'll encounter issues and you don't want to be holding up being productive over some weird issues that you can't figure out, and then you have to dig around in random GitHub issues and ping random people trying to figure out what is going on. Yeah, this has been the talk. Thanks everybody so much for joining, and I'll be super happy to try to answer any questions. Don't know if it'll work, but yeah, we can try. I think you can ask questions through the chat on YouTube, Facebook, and Twitter. So yeah.
Cool. Well, while we're waiting for people, I'll just pose one that's interesting. So we actually tried Flow Turbine. We had a lot of those same problems, but we got it to work for a bunch of our tests. We noticed that the official Google Docs actually still recommend doing pause dispatcher, resume dispatcher. And it does actually make some interesting tests where you can kind of pause, resume, and go through and kind of walk through your test. Have you tried doing it that approach?
No, I haven't. Actually, I wasn't aware of that, but I'll be sure to try that out. Does that so how does it work? Did you do that in your test code?
Yeah, we did it in our test code, and it does actually work. You can say right away in your tests, like pause the dispatcher, and then later on, once you set up all your collects and everything, you can say resume dispatcher, and you don't need run blocking anymore.
Gotcha. So that's when you're using test coroutine dispatcher, right? Or is that
you create a test coroutine dispatcher rule that returns the dispatcher.
Yes.
And then you reference that to then pause and resume it.
Actually, I have tried to use that, but I did have some issues with that where things were really weird. That was in some eye tests, and that was a very weird use case. So I've got to give that a shot again, because that would be great. Not to be bound to run blocking anymore or run blocking tests. I've heard from some other people too that they just have their own suspend test functions instead of run blocking tests, that do kind of similar things as run blocking tests, but don't give you the issues and use run blocking underneath. So yeah.
There was another thing we were dealing with, which is that we had a single live event class we created for having live data for things like a snack bar or a progress dialog that you wanted to only consume once and then not pop up multiple times. We've actually found we were using the biggest blog on this topic suggested doing a bare channel with a buffered style. But my research in that found out that that's actually only consumed by one of the people listening, the first one to get it, basically, which is bad, I think. So what we ended up doing is a shared flow of 0. Does an amazing job as an event bus or as a single live event.
Yeah. Yes, exactly. It's a great use case for that, especially over conflated broadcast channel or a single live event. It's kind of nice to be able, to use uniform APIs as far as possible. That's great.
Do we have any questions here? I'm just watching.
I haven't seen any come in.
Yeah. You can wait and chat a little bit.
Yeah.
Next month, I'm hoping to, so the Kotlin 1.5 global event is coming up very soon, right after Google I/O. And what I'm hoping to do next month is basically just do a panel, talk about what happened in the global event. Because what I remember last year was there were a lot of talks. And it seemed like during the global event, like it wasn't easy to watch all of them and to get kind of a feel for what was really valuable, what was what applies to me as an ex-Android web multi-platform developer, whatever I'm working on. So I think it'll be fun to do a panel just going over what went down, what's new in 1.5.
That personally, I'd be really happy about that. I'd watch it. So
cool.
Well, as long as you do it over lunchtime, I guess.
We might actually pick this time because I feel like it's easier for a lot of people.
EU folks agree, or actually EU and African folks agree. Cool. If we don't have any questions, should we close this? And I'll post the link to the slides on Twitter later today or tomorrow, depending on how tired I am. Thanks everybody so much for joining. And yeah.
Thanks everyone for coming. Sorry about the technical issues. We'll have them entirely ironed out next time. I'm learning so much about the tooling, so.
Me too. Thanks, Yuan. All right. Well then, I should have to figure out how to drop off, as always.
I do too. It's funny. See you
All
guys.
right. Well then, cheers.